Yes, welcome to Easy Gates Gate 22 Instrumentation Paper Solutions. Next problem from measurements. As per the master question paper, it is problem number 63. Okay. Yes, that's a problem. We have a bridge. The moment you see the bridge, you will understand that's a Maxwell's inductance capacitance bridge. The bridge is said to be in balance. So balance condition values are given. That's a very simple problem. Even if you begin from the scratch, you'll get the answer instantly, quickly. So under the balance condition, R1 is mentioned, R2 is mentioned, the capacitor is given, R2, C2 is given, so R4 is given. So what we need to find out is the value of L3. Okay, yes. So there are two ways to answer the problem. One is going for the full balance condition of the bridge. Okay, going for the full balance condition of the bridge. Another one is straight away playing for the phase balance also. Okay, for that we need probably some of the other values as well. We'll check. Okay, so let me try for the phase balance. So the phase angle contributed by this is θ1, that is equal to 0 degree, and phase angle contributed by this is equal to θ4, that is equal to 0 degree. That means sum of opposite phase angles θ1 plus θ4 is equal to 0 degree. So under the balance condition means then sum of this angle and this angle should be equal to 0 degree. That means θ2 plus θ3 must be equal to 0 degree. So θ2 contributed by whom means Z3. What is Z3? Z3 is equal to R3 plus J omega L3 you will get. That's your Z3. Then what about your Z2? Z2 is equal to R2 divided by habit. Already many problems happened. Straight away you can take this with R and C in parallel. So SR2C2 plus 1. Okay, then Z2 of j omega, we can say Z2 of j omega as R2 divided by j omega R2 C2 plus 1. Okay, so we can play with them. So we can play for θ2 and θ3. So what, and sum must be, this phase angle must be equal to 0. Okay, so what is θ2? θ2 angle of Z2, that is going to be minus tan inverse of omega R2 C2. Okay, that's your θ2, and θ3 is going to be tan inverse of imaginary by real, that is omega L3 by R3. So if you balance this, that means θ2, okay, plus θ3 must be equal to 0 means, so tan inverse of omega L3 by R3 minus tan inverse of omega R2 C2 must be equal to what? 0. If that is the case, omega L3 by R3 must be equal to omega R2 into C2. Okay, is omega given? Yes, the frequency of excitation is given. For the bridge, omega is given. Anyway, omega is getting cancelled. So then straight away from this, I can pick my L3. L3 is equal to R2 R3 C2. L3 is equal to R2 R3 C2. That's it. So that's by a simple phase balance. Even if you begin, yes, you have to play. Okay, you should know, okay, whether we need to go for the complete balance of the bridge or simply the phase balance alone, we can get the solution or not. Means yes. Okay, this is the simplest route by playing with the phase angles of all the impedances in the simple Maxwell's inductance capacitance bridge. Okay, so what are the data available? R2 available. Okay, R2 is available, C2 is available, but what is missing? R3 is missing. Yes, that's a trouble we have in the phase balance route. I thought, okay, so yes, that's unknown inductor. So we have to go by the complete balance otherwise. Okay, so then what is a complete balance? So we can write R1, R4, that is equal to R1, R4 is equal to, then it is R2 by SR2 C2 plus 1. That's impedance Z2, and Z3 is equal to, yes, these two are opposite, that product, and these two are opposite, this product must be equal. Okay, that's a complete balance. So that goes like Z1 Z4 should be equal to Z2 into Z3. I'm expanding it. So Z3 is R3 plus S into L3. So we'll expand this. So if I expand this, I'll end up with R1 R4 into S into R2 C2 plus R1, R4 I will get on left hand side. Right hand side will be R2, R3 plus S into L3 into S into L3 into R2. Okay, now we are looking for the real balance. This is going to be the imaginary and this is the real. If I set S equal to j omega, straight away let us play. This is again the real, this is the imaginary. So now already we have the expression based on L3. We need only the value of R3. Okay, let us get R3 and then we'll complete the problem of L3. Okay, so what is L3 now? What is your balance for real? So it is R1, R4. That should be equal to R2, R3. So then who is only unknown? R3. R3 is equal to R1, R4 by R1, R4 by R2. Okay, yes, let me check. R1, R4 by R2 will be the R3, just like a waistone bitch. It resembles just like a waistone bitch. And already we got our L3. L3 is equal to by phase balance. So R2, R3, C2. Okay, so here also you'll get the same if you compare these two. Okay, so R2 will get cancelled, then we'll get 1 minute. Let me check. L3 is, if I check it here, then what is the balance? If there is a case, because that L3 demands R3 as well. So if I compare these two, then it is going to be yes, R2, C2, R1, R4, that is equal to yes, L3 into R2. So then R2 it is, R2 will get cancelled, yes will get cancelled. Okay, then L3 is equal to yes, R1, R4 and C2. This is straightforward because R1 is given, R4 is given, C2 is given. So therefore L3 is equal to R1, R4, C2. Let me have a small check. Okay, seems to be fine. So let us get the values. R1 is 100. What value we are looking for? R4 as well. Okay, R1 is 100, R4 is 50. So this is 100 ohms and this is 50 ohms. And C2 is given 2.9 microfarad. That's all. So this is your L effective is R square into C. Okay, yes, that's an unknown inductor. L3. So 100 into 50 is going to be, so it's 5 into 10 power 3, then into 2.9 into 10 power minus 6, and the result must be in millihenry and up to 2 decimal places. So then it is going to be 5 into 2.9 into 10 power minus 3 Henry. So this will become millihenry. So the answer is 5 into 2.9. So millihenry. 5 into 2.9 will be, so can manually do it. 5 into 2, 10, 5 into 9, 4.5, 0.9, 4.5 plus, yes, you can say 14.5 millihenry. Let me have a small check anyway. 5 into 2.9. Okay, yes. So that's a perfect answer. So problem is talking about only the unknown inductor. And if you remember this, it is a straightforward problem. Okay, so but it's not easy to remember. We don't know where our inductor is placed because it is going to be function of 2 Rs and 1 capacitor. Okay, so better to go by the balance condition, and then if required, okay, sometimes problem will be made for R3 also, but in this case, luckily you don't have a problem for R3, you have a problem only for the L3. Okay, it's unknown coil. Both R3 and L3 are unknowns, remember that. Okay, and problem is very simple because the bridge is already in balance. Okay, going for the unknown inductor. So in this case, you not use the frequency of the excitation, not required. Okay, with that, without that, we can still complete the problem. Okay, but if it is a phase angle route, then definitely we need that frequency. But the problem is in the phase angle route, we got the expression, but it is function of the unknown of the unknown resistance of the coil itself, so we can't complete the problem. Okay, so yes, the earlier practice with this bridges should have given you the idea what route we should take, whether to go by phase angle or go by the complete balance. Okay, so I tried the phase balance route, assuming we can complete the problem quickly, but that doesn't work. Okay, so we went by normal way of the total impedance balance. Product of opposite impedances are equal when an AC bridge is said to be in balance. So that's another interesting problem from measurements. Easy. Okay, so in gate 22 instrumentation, comparing to the last year measurement problems, this year all the measurement problems are very easy to answer. Okay, comparing to gate 21 standard. Okay, so it's a easy paper comparing to gate 22 in many aspects. So thanks for watching. We'll update you with the next problem soon. And do subscribe the channel and also share to friends. Okay. And another information. Yes. So we have already opened the batches for gate 23 and gate 24, especially for EEE mechanical, E&I, CSC and biomedical streams. Okay. So classes are already going on. Okay. Both physical weekend as well as regular classes. Online admissions also going on. Students who are willing to join online live courses, yes, you can refer the site. So even you can refer the phone number, you can WhatsApp or you can call us. Okay.